With this tutorial I want to point you on an included feature of Excel which is often not known. Excel is equipped with an iterative solver which can be used to run optimization problems, or it's called Extremwertaufgaben, to solve those issues. You have to activate this. It's an add-in via the options menu of Excel, then go to add-ins, and here the solver tool has to be added. With this setting you have then in the data ribbon of Excel a new solver button which can be used to run through iterative problems. As example, I've taken the classical CAN problem. That means you can use the solver to solve optimization problems which are related to multiple dependent parameters. In this case, in this classical example, we have a can, which is nothing more than a simple cylinder, and we want to optimize it in two directions. The first one is the volume should be more or less exactly 1000 cubic millimeters, while the area, the surface area of the entire can, should be as less as possible to avoid material efforts on the final design. No doubt this can be solved by other tools too, but it can also be solved directly within an Excel. In this case, I have created these two flexible parameters as cells: the diameter and the height of the cylinder, and I have included a few support calculations, like calculating the perimeter on the upper surface, then also the circular plate, the surface area of the circular plate, and also the lateral surface area, both combined to the entire surface of the can, of the cylinder, and the volume can also be calculated by taking the base plate and extrude it along the height of the cylinder. If you start with the solver, you have the capability to run into multiple options, and I have taken here the evolutionary algorithm with a few optimizations regarding the convergence criteria to achieve very accurate results. And then you have to start with a target cell. That's in my case the cell A11. This is my surface area, calculated surface area of the entire can. I want to target it as minimum. That means the solver try to minimize that value. Then I have marked the flexible cells. That means which are the variables the solver can vary during iteration procedures. These are cells A2 and A3. And then I have added a few constraints the solver should take care for during iterations. The one is that the entire volume should be exactly 1000 cubic millimeters, and I have added also a few ranges for the flexible parameters to avoid that the solver is running out of range for this parameters. And then I can simply run into the solution, and now the machine is running through thousands of iteration steps in a very quick time to try to optimize these parameters to come as close as possible to our target. And you can see here how the parameters are optimized. Depending on the accuracy and the solver type you have chosen, it could be a rough solution could be achieved very quick. Maybe if you want to have it more accurate, the solution takes a few seconds longer. Okay, the solver have finalized the iteration procedure, and you see the target volume is calculated very close to our original target, while the resulting surface area is minimized as max. And these are the resulting diameters, and the resulting diameter and the height of the can you can use for your design process as target options. The advantage of the Excel included solver is that you can use it on a lot of on a very broad range of iteration problems you have, as long as you can create the equations in a proper way and build in the internal relationships like it is done here for this classical cylinder example.